Hello guys, this is me again. This is a new video about optimization. So in this video, we are going to optimize a cylinder. What is to optimize? Basically guys, is to use the minimum or the maximum to find the best value to satisfy certain conditions. For example, in the IV, we have two super popular examples when we need to optimize a cylinder and also a box. In this context, to optimize the cylinder and the top or the open top box is to find the less amount of material needed to build a cylinder or the least amount of material to build a box. Okay, that would be optimization. So we have example number one. In this example, we need to optimize a cylinder because we have you run a company that makes cat food. This cat food is a can. The can be modeled by a cylinder, so it's a math representation of this can. So the can has some volume, okay. Then we have the radius of the can is r in centimeters and height h in centimeters. So we need to remember something before this. Let me show you this. Okay, and let's go here. Pay attention to this. Guys, when we are talking about optimization exercises, we are going to use surface area. What is the surface area? Guys, when we have a cylinder, if we need to build a cylinder, pay attention to this. We need first a circle, then a rectangle, then a new, well, this has to be a circle, then a circle. So this would be the template to what? To build our can, okay? So the template uses an area. That would be the surface area. If we sum this circle plus this circle plus these rectangles area, this would be the surface area, okay? So here we have the surface area is given by this, but how can we know? Just as a reminder, the circle has the circles area. We need circles area is given by what? By pi radius squared. Okay, as always. So pay attention. If we want to find the surface area, so we need the circle, the circle plus this one. Okay, so we have 2 times what? Pi radius squared. So this is this section of the formula. Plus what? Pay attention. What is this rectangle? This one. We need plus this area. So we need to remember this, the circumference or the perimeter of a circle. The perimeter of a circle, this one, is given by, we have 2 ways to represent this. Pi times diameter, or we can say 2 times pi times radius. So the perimeter, or the circumference of the circle, is the length, this length, of the rectangles of the can, or the cylinder. Then obviously, the height is going to be the second side of this rectangle. So if you want to find this area, because it's a rectangle, is this 2 times pi times radius, okay, the circumference times the height, as always. If you remember, is this times this, okay, when we have a rectangle. So using the formula, we can say plus 2 times pi radius times h. That's it. So this is the same as this. So we are saying the total surface area, the 2 circles plus the rectangle, is this. Okay. So we must consider this. Explain why pi radius squared times h is 200. This is a little bit obvious because let me show you something. A cylinder is a 3D shape, okay? So the cylinder has a volume. You can say you can keep or hold things inside the cylinder. So the volume is given by this. Okay, if you don't remember, this is the formula for finding the volume. Pi times radius squared times h. Okay, so in the exercise here, the exercise is telling you the can, this one, holds 200 centimeters cube. Okay, when we have centimeters cube, this means that this is volume. Okay, so pay attention. For A, we have the volume of any cylinder is pi radius squared times h. And then the problem is telling you the volume of this can is 200 centimeters cube. So we can equalize this. So we can set the volume of any cylinder equals to the volume of the can. So explain why. When we have explained, we need to write down something. So we need to say because the can be modeled as a cylinder. And that's it. Okay, this is a little bit obvious. So because the can is a cylinder, this is the model that we can use. Okay, then for B, rearrange the equation from part A to make H the subject. What is the meaning of make H the subject? Basically to isolate H. Okay, so for B, when we have here B, we have this equation, pi times radius squared times h equals 200 centimeters cube. So we need to isolate h. So we can isolate h, easy peasy. These pi and radius squared, they are multiplying the h, so we need to do the opposite operation. Basically, this is 200 divided by pi radius squared. That's it. This is B. Okay, now we have h equals something, that is, make h the subject. Then C, find an expression for the total surface area of the can or the cylinder. Okay, so we already have this. Okay, so C, this one. Remember, this is the template. This is like the template that we have to build the cylinder. So two circles plus, so this is circle, then this is the rectangle. Okay, so we already have this. Okay, continue with the example. We have D. Substitute your expression for H into your expression for S. In this case, we are going to use, let's use SA. SA, because this is surface area, okay? And hence show that the surface area is given by this. So basically, they are giving us the result, okay? But we need to verify that if we take, pay attention, if we take this H and use it here, because this is the height and this is the height. So if we use this expression here inside, we have to have this result. Okay, so what we are going to do for D, let me show you here, D. So we can say the surface area is 2 times pi radius squared plus 2 times pi radius, and here comes a trick. What is our H? Remember, 200 divided by pi radius squared. Okay, so we have substituted the value. Then what else? We need to simplify using algebra. So we can say this surface area is 2 times pi radius squared plus, what can we do here? We can, here, okay, we have a pi, this one. We can neutralize this, or cancel out. And also, these are to the power of 2, we can cancel out 1r. Okay, so we can say this neutralizes with this one, with this one. Then we can multiply 2 times 200 because this is like a fraction. If you remember, when we have fraction, this is like having this fraction, so we can multiply like this. Okay, so we have 2 times 200. Obviously, this is 400 divided by r, and that's it. This is the result. But you can see, hence show that. So we have 2 pi radius squared, the same, plus 400 divided by r. Okay, this is d. Okay, then we are going to use the calculator because we have using assignable scales for your axis, plot the graph. Remember, when we have plot the graph, it's different than sketch the graph. Plot the graph is to use your calculator and see on your calculator the graph. If we have a sketch, we need to build or to draw here the graph. This is not our case. Then using the calculator, we're going to find the minimum and what is the minimum? Only the minimum. Then guys, once that we have the surface area given by this, okay, show you that we have this expression that represents the template that we are going to use to build the cylinder. So then we are going to use the calculator to find the minimum point. Okay, so please, with your calculator here, we need to go first to graph. Then here in graph, we are going to add this equation. Exactly the same. 2 times pi. In order to add pi, we need to press shift and this key times. Remember, the calculator doesn't have r. What we can use is the x squared plus then the fraction 400. Then we press down divided by x. Okay, x is going to be our r. So then we can press execute. Then we press draw. Okay, if we cannot see anything like this, we can use, for example, zoom, automatic zoom. If you, okay, I don't like it. The option 2, we can modify the view window so we can change the x-axis and y-axis. We can use standard, execute, draw. Then we can press zoom out. Let me see, zoom automatic. Maybe like this. Then zoom in, that's it. Okay, this is the graph. This is our graph that we are looking for. Something like this. Okay, once that we have this, pay attention that one. Let me zoom out. We don't care, we don't mind about this section because this is negative. And remember, this graph represents surface area. We cannot have a negative surface area. So they are asking for find the minimum. So in order to find the minimum, easy peasy, we can use gsolve minimum. So now we have this. Let me copy this. So remember, the x is over r. So this is like r equals 3.17. Let's round up this. Y is the surface area. The surface area is 189.32 centimeters square. But what is the meaning of this, guys? So this means that if we have, let me copy this. Well, if we have this equation that represents the template of the cylinder, and we cut, what is r? R is the radius. Which radius? The radius of the cylinder. So if we cut this, if we have this circle with a radius of what? 3.17 centimeters, okay, we can build the cylinder. But remember, the cylinder has a radius and also has the height. But if you remember, we have an expression for the height at the very beginning, we were saying that the height is given by what? This one, 200 divided by pi times radius squared. So we have 200 divided by pi radius squared. So we already have the radius, so we can find the height. So we have 200 divided by pi times 3.17 squared. Using my calculator, this is 6.36 centimeters. So pay attention to this. This means, guys, that we need a circle, well, two circles. We need two circles, 1, 2, with this radius, 3.17, the radius 3.17 centimeters, and then the height, we remember we have something like this, the height is going to be 6.36 centimeters. Okay, if we build a cylinder following this, we can have a cylinder with what? With 200 centimeters cube, to keep or to hold the foot, and at the same time using the less amount of material. That is the meaning of optimization. And that's it.